Good afternoon and welcome to the Polygon Composites Bushings webinar. Thank you all for joining us. Looks like we've got a few other people signing in, but we're going to go ahead and get started. I've made you guys wait long enough. So again, I appreciate you all taking the time to join us today. We've scheduled about an hour for this, but I'm going to be honest, we're going to do our best to keep it short for you guys. We respect your time as well. So roughly 30 minutes or so, with some time for questions at the end. So yeah, roughly 30 minutes. Also, we're gonna make this a little bit more interactive. So you're gonna see some pop-up questions during the webinar. And these are just gonna be some poll questions where we wanna get some feedback from you guys in the audience, because let's face it, you're the ones with the experience and we wanna hear from you. Lastly, anytime throughout this webinar, please feel free to submit your questions in the Q&A feature. And if you highlight your screen, it should be somewhere down in the middle of your screen, the Q&A. You can just type out your questions and we'll read those throughout the webinar. And if I can't answer them, we can't answer them, you might be hearing from one of our other speakers today. At the very end, we'll also have our email addresses, so you can reach out to us that way as well. My name is Linda Brantley. I've been with Polygon for a little over 17 years now. We're also going to be hearing from Kent Eubank. He's logging in remotely from Iowa. He's got many years in the industry, and the last 15 of which have been with Polygon. He's worked with a number of large OEMs as well. Jason Kowski is chiming in. He's located here in Indiana. He brings 20 years of bushings experience to the table. So the overall goal of our presentation today is just to introduce you to the Composite Solutions and the benefits from efficiencies that they can bring. All right, here's our first pop-up question. We are interested in knowing how much experience you guys have with composites. So if you could, take a second, answer this question, and I'm going to share the results in about 15 seconds. All right, looks like, all right, you guys have some good experience. 3 or more projects experience seems to be the answer. So that's great. We're glad to hear it. Hopefully you can learn something from this webinar and we can have additional projects in the future. So let's kick this off by just having a basic understanding of what a sleeve bushing is. An example of the sleeve bushing is shown here. And typical locations on a piece of equipment can include hydraulic cylinder ends and pivot locations where that motion is created. Now, there's going to be many trade-offs when you're looking to pick your bushing or bearing, and those trade-offs are going to include lubrication requirements and serviceability. I'm sure you guys know no single bearing type is perfect at everything. All right, have you guys ever seen one of the bushings that look like these on the right? So these are just some specific examples, but there are many other failure modes. Let's go through some of those challenges in more detail. Pin damage is mostly noticeable when it's broken or significantly worn. And common causes of pin damage are galling or scoring from contamination, just to name a few. Joint seizure, that's often caused by inadequate lubrication. And since most of these bearings rely on added lubricant to separate the two metal surfaces, this basically is a catastrophic failure. Now your joint doesn't want to move at all as it should. And you might want to go ahead and call maintenance. For the attendees, here's our next pop-up question. What type of lubrication schedule do you guys currently have on your equipment? Maybe it's daily, seasonally, maybe it's just based on the operational hours. So go ahead and take a second to answer. And again, we're going to share the results in about 15 seconds. Really appreciate your participation and your feedback. All right, the results show based on operating hours. Kent, do you have something you want to comment on that? Does that seem right to you?
Yeah, Linda, that's pretty common. Most everyone, measures their maintenance increments in operational hours. If we'd have seen a little bit higher numbers in seasonal, that might indicate more ag uh, clients were joining us because they're going to maintain their piece of equipment before they put it out for the season. So this is pretty typical. Not
Awesome.
surprised.
Thank you, Kent. Noise and chatter. Sometimes noise or chatter, that can be an indication of inadequate lubrication as well. Properly separated surfaces don't make noise. And some materials can experience a stick slip and have excess vibration. Nobody wants to be out in a 135-foot boom lift that's chattering, do they? Not me. When materials can't handle the loading that they're subjected to, they fail structurally. For example, fatigue cracking. You can see that in the image on the right here. Stress concentrations or edge loading, those are also common challenges. Another question for the attendees, not a pop-up, but just a question to think about. Have you guys ever had to replace a bushing in the field? Difficult, very difficult to change bushings in the field, especially when that bushing failure is going to be combined with pin and other component damage. Sometimes it becomes impossible to separate those components with the tools that you have on hand. So extending the life of the bushing and preventing pin damage would reduce that service downtime. Finally, warranty claims. Lubrication issues are one of the leading causes of warranty claims. All right, a final pop-up question. Remember when I asked you guys what your lubrication schedule was? All right, so now, how often do you really think that's happening? Again, we appreciate your feedback and your participation in this. It's gonna be interesting to see these results. 15 seconds, and I'm gonna share that with you. All right, I don't think we're surprised by this, guys. Less than 50% of recommended schedule was the biggest answer, the most common answer. You know what, and that kind of brings me to that joke that we often hear, that the equipment usually only gets greased 2 times. Once when it leaves the assembly line, and then once right before it's returned for warranty work. So yep, that makes sense. Enough about all the challenges. Now we're going to talk about composite solutions, the composite advantage. Our composites have Teflon filaments embedded in the wear surface. They won't rust. They are strong and can replace hardened steel sleeves in applications like these examples. And they're easy to retrofit. And we're going to get into more of detail on that shortly. So now let's hear from Jason.
Thanks, Linda. Composites are made by combining multiple materials with different properties to become even better than the individual materials by themselves. The materials can be interchanged to optimize performance for a given application and operating conditions. In the image on the upper right, our composite bushings basically have 2 sections, one to support the application forces and one to provide the self-lubricating wear surface. The strength of the composite bushing comes from the combination of continuous fiber reinforcement and the resin matrix that bonds all the fibers together. Unlike metal, composites have direction-dependent properties that can be optimized for the application. The pictured Teflon-rich liner is one example of what we construct in-house to become the wear surface. And this is locked into the composite matrix, typically on the inside diameter.
Jason, thank you for that. Here's a question that just came in. I'd like you to answer. Can you do a 10-inch diameter bushing?
So the answer is yes. We make a variety of sizes, basically down to about 1/4 inch in diameter, all the way up to approximately 30 inches in diameter.
Thank you. I think that's going to answer our viewers' question. Kent, could you go ahead and give us some examples of the challenges that you see in the field?
Yeah, sure. Thanks, Linda. A common example is on ag equipment, agricultural equipment, and aerial work platforms where each unit has dozens of grease locations to be maintained, many times on a daily basis. This type of maintenance is usually performed by the operator, or in the case of construction equipment that has very difficult to access locations. Oftentimes those locations might be underneath the chassis where an operator or a maintenance person has to remove a lot of debris, dirt and debris that might have built up around a grease point, or simply in the case of aerial equipment or booms where the height of that maintenance location is out of reach to easily get to. So basically, anytime an operator can reduce his scheduled maintenance responsibilities, the more time he has to actually operate his equipment. And that makes operators very happy. And we all know that we like to keep operators happy in their jobs. Another more unique story we're hearing more and more comes from OEMs that provide units to the rental fleets or rental yards. Those fleet owners know that when they lease a piece of equipment, the chance that it will be maintained is at best minimal. By using a maintenance-free bushing, they are assured a predictable life for that piece of equipment in their fleet, and that they know it'll operate for the next customer that leases that piece of equipment. So they know when it leaves, it's going to come back in the same condition when they leased it. All in all, both these examples that I gave have the same goal, which is reduced maintenance and more productive hours for the manufacturer or owner. So many of our customers, the OEMs that we work with, are broad in nature, the types of sectors. They range from construction equipment of all sizes, whether it's mining, the very large equipment, to residential construction or road construction equipment, which we see all the time in our daily lives, to ag implements. Ag implements, the primary users are tillage and planters, which use many bushings, harvesting or foraging equipment, or even capital equipment like combines and track bogies, which are pictured here on the upper right, where you'll find our bushings as well. Next on the list are material handling, such as forklifts, aerials used on work trucks, and work platforms, let's say in the boom structures. The work platforms are illustrated in the lower picture. Has many locations and sometimes hard to access locations simply, once again, because of the height. All these different categories that we have listed here have one thing in common, and that's fluid power. Fluid power to polygon means hydraulic cylinders. And hydraulic cylinders are, of course, found on each and every one of these items. Polygon works with cylinder manufacturers to provide bushings in rod and base locations, which usually the OEMs help specify, as well as composite tubes, which Polygon also manufactures. Composite tubes are used on occasion by fluid power manufacturers.
Hence, a question just came in, if you wouldn't mind answering, please.
Sure.
Can we still grease the bushings?
Yes, we have no problems greasing the bushing or grease being in the presence of the bushing. There's really no detriment to that. between the grease and the bushing material. So the answer is yes.
Thank you, Kent.
Sure. When you were designing a bushing, and this is interaction with our customers, regardless of what industry you work in, our customers need to work with us. We form a partnership. OEMs come to us in need of a solution, and it's critical that we know the full application story, before we offer a solution. Prints for the housing and pin or shaft dimensions are most important to properly size the bushing to fit the existing metal components. We size our bushing for a tight press fit to the housing without changing any current production components. In other words, if you had an existing pin or an existing housing bore that you have in place, we're going to design and manufacture a bushing to fit in that location. This press fit that we talk about that we need to design around with the housing is extremely important for retention of that bushing and to eliminate any migration of that bushing once it's in operation and oscillating in that joint, or a joint oscillating around it. Also, other conditions that we like to review before we offer a solution to customers are any impacts that we might know of in its life cycle, pin treatments such as coatings, hardened pins, things that we need to know up front, or can offer suggestions to help with a great solution for a customer. And basically any environments that we might see out in the field or the customer experiences, whether it's dirt, mud, like underneath the chassis, that might migrate into the location, soil conditions in the case of ag, which, different parts of the country have a lot of different soil conditions, different parts of the world that might affect bushings differently. If the bushing is subjected to being submerged, whether it's in an oil bath, perhaps, or liquids, or contamination where it's digging into water laced with mud that we might experience in that bushing location, and also heat and high cycles. High cycles might occur in ag equipment where they have multiple hours or acres that piece of equipment is operating under high cycle conditions. So we need to really know the whole story behind how this piece of equipment is being operated or intended to be operated by your customer. And finally, one last point is it's helpful to have some sort of CAD image or an explanation of the application to complete the story. That information helps us to better envision the application, so we can review from our past experiences for a solution that would best solve your application or your concern. So going along with that experience and stories and applications and what works and what doesn't work, Polygon's experience of and collection of these case studies is a huge benefit to our OEM customers. Combined with a long history in composites that's resulted in many patents and technologies that are unique to Polygon. Over the years, we've developed solutions based on the voice of our customer. That's a term we hear quite often, is VOC, voice of customer, and what the OEM's customers' expectations are, and then we try to build that into our solution. Customers are always challenging us with new situations. Consequently, Polygon is continually introducing new materials and techniques to the marketplace to solve those puzzles. Every day, our engineers are dedicated and strictly focused on a composite answer. And that's what we rely on Jason for, is helping us collect that story and dissect what might be an issue and what might be a solution, and find a composite answer for that. This singular focus has made Polygon Composite Technologies a global leader and a solutions partner for all of our customers. Our OEMs depend on us, calling for our expertise many, many times a day. And quite frankly, we hope you give us a call so we can help you with your concerns as well.
Kent, thank you for that.
Not a problem, Linda.
For our listeners, if you guys are interested in learning more, please reach out to us. We can schedule a time to discuss your application specifics or to arrange an engineering seminar. Before this COVID era, we would set up what we called lunch and learns, where we would Polygon would bring in pizzas or lunch from like a local restaurant in your area. We could have a nice, relaxed roundtable discussion. And this allows our team to meet with your designers and learn hands-on all about your project details. We can also do virtual meetings such as this using Zoom or Microsoft Teams, for example. Now let's take a few questions that came in. Let me scroll through a few. One that came in is, do you make flange bushings? I'm going to answer this one for you. The answer is yes. We can machine our bushing material. We can do grooves, outside diameters, inside diameter chamfers. We can do the flanges. Basically, any feature that a metal bushing can have, our composites can have, and that includes holes as well. We're going to scroll through here. Oh, good one. Typical lead times for your prototypes. So testing prototypes are typically provided in, let's say, 2 to 3 weeks, but that's going to very much depend on the scope of your project, the materials involved, and things like that, but roughly 2 to 3 weeks for that. Looks like we're getting some other questions in. And I'm going to be honest, it looks like some of these might be better answered with a non-disclosure agreement in place. And if that is the case, then our team will be connecting with you separately to have like a one-on-one conversation to better determine whether our composites are going to be able to provide you a solution. Jason, I believe one came in. Did you want to answer anything online there?
Sure, I'll just, so the question was, what tolerance fit for press fit do you have? And I'll just say, it varies on size, but typically what we do is we ask for customers to provide the housing dimension and shaft dimensions, and we will work with those tolerances to figure out what's our best, most appropriate fit for the application.
Great, thank you, Jason. Very good. So for all the listeners out there, if we didn't get to your question today during this webinar, we highly encourage you to submit your inquiry to either my email or to Kent's email listed here. You also include any engineering type questions. We'll definitely be working with Jason, our engineer here, and make sure that we can get that solution for you. We appreciate your time today. We appreciate you guys participating in our pop-up questions, our little poll questions there. And definitely, again, reach out to us. Our goal today is to make sure that we are here to provide a solution for your application. So we highly encourage you to reach out to us, and we definitely look forward to hearing from you. Thank you all again so much. Thank you, Kent and Jason, as well. Have a great day.
Great. Thank you, Linda.